Hey everybody, what we're going to be doing today is using linear regression for predicting market movements. We're just going to go through a quick overview of what linear regression is, and then I'll apply it to what it would look like for a time series analysis. I won't actually be pulling any data in this, but it should still provide a good overview on how it works. So thankfully, because it's going to be a simple notebook, we don't need to import much. Just, we're going to get some random numbers to act as our data, and then we'll just be needing pandas and numpy. We won't be using any like sklearn or, scikit-learn or whatever pre-made package. We'll just be using methods within the numpy package. So let's go over a quick idea of what linear regression is. I'm just going to create a grid between 0 and 10, and then we need to fix the seed for the random numbers generated. And then we need to generate our y values. We're just going to take a random set of standard, numbers for the length of x, and we've defined x as between 0 and 10, right? And then so this is where it gets interesting. So numpy has a ordinary least square linear regression in the form of polyfit, and we just pass through our x values and our y values, set a degree, and we're just going to set that as regression. And to show you what that looks like, it's a simple array, right? So let's plot that along with the linear regression line. So we're going to plot our x and y values. That's going to equal our data. And then we're going to plot the regression line. And we get something that looks a little bit like this. If you've seen linear regression or any kind of regression in my previous videos, this graph is going to look pretty simple. We have our x values between 0 and 10. And then we have also our y values and the data that we plotted at random. And the polyfit is this linear regression line here. So ordinary least square just refers to the distance between the data point and the line. And you're taking the square root of the error there. So you're just trying to find the line that most represents the direction of the data. So you can imagine in a market movement, if you have a bunch of data points going up and down, but if there's a trend line, you can predict between a space of data where this momentum is going. Not necessarily a momentum strategy, but you're just using the direction of the data points on the regression line to predict whether it's going up or down. So we can visualize this by extending our x values by doubling it to 20 and predicting without any data past 10 where this linear regression line would go. It's going to be pretty simple in this example here. As you can see, it just continues to extend up. So when we zoom out a little bit on our x values here, we can see that the data points get clustered together closer to the line as the resolution backs out. And so we can say with pretty good confidence that whatever this data is representing is going to continue to move along this line. So what would it look like for a basic price prediction using this method? So we'll do the same thing. We'll create a time series model, we'll do the same thing. We'll set our x as a set of numbers between 0 and 11. So these are our prices here for the x. And for time series, when you want to predict what the next series will be, what the next number in the series will be, you first need to know what the lag is. So what were the past values and you're going to use the past values to predict what the future value is going to be. So in this instance, we're just going to put our lag as 3. So if we're trying to predict 9, we'll use 6, 7, 8 to predict what the next number will be. All right. So all this is doing is saying that our m lags is equal to, we're essentially assigning m lags from our x lags and onward dependent variable data. And then we'll also create independent variables. So for each value in the range of our lags, our mi, right, is going to be equal that minus the lags. It's a little confusing, but when I show you what m transpose looks like, it looks like this. So essentially we have the first 3 columns are the known values, and this is going to be our predicted value. So we need all of this data to train our linear regression model. And what we'll be doing is feeding in the first 3, which is our lags in the data set, to predict our 4th column value here. And we'll know whether the model is performing well because we'll actually know what this value is here. It's pretty simple. It's just going up by 1. So 5, 6, 7. Next value is going to be 8. 6, 7, 8. Next value is going to be 9. So pretty simple. I think an elementary school would be able to understand this, and an elementary school kid would be able to predict what comes after 2 if the series is 0, 1, 2, right? But obviously this gets more complicated with time goes on, and I'll show you how more complicated, or I'll show you a more complex model we can use to help predict this column here. But for our purposes, you just need to remember columns 1, 2, 3 are the lag values that we'll be using to predict the 4th column. So because we're not going to be using like a sklearn pre-made linear regression package, numpy has this linear algebra least squared methods that will pretty much do the same thing. We'll pass through our first 3 transposed array, and then we'll have our lags here, and then we're just going to set the R condition to 0, right? So to show you what this looks like, these are fitting the parameters of our model to help us determine our predictions, and the dot just performs the prediction using our regression parameters. And you can see we have 3, 4, 5, 6, 7, 8, 9, 10. So when I first did this exercise, I was kind of like, what does this mean? I simplified it. It should just match this column here. Excuse me, the 4th column here. 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's basically it. If you replace these here with a price, the same concept would work. You just we're just using pretty basic values here. All right, so you might be wondering, like, that was a little too simple. Everett, just show us what it looks like using a real-world data set. So we'll be using linear regression to predict the index level of the euro to US dollar. We're just going to use Y Finance, maybe one of my favorite finance packages for playing around with this kind of stuff. We're going to keep it pretty simple. We're not going to be using any pre-made machine learning packages. We'll just continue to use the numpy linear algebra least squared methods. I'm going to pull a decade's worth of data. We're just going to be using the adjusted close price. We've got about 2,646 entries there. And like I said, we're going to pull a decade's worth of data. So if we look at the head of our data frame here, you can see it starts 2013, January 1st at 1.3, right? So, and then it just goes up. So remember, when we're forecasting, we need to set a lag term to look at the last amount of days to predict the next day. So in this instance, we'll be looking at 5. So we'll be looking at days 1, 2, 3, 4, and 7 to predict what January 2013 on the 8th day would be. So we're just going to create a column of our adjusted close with the lags appended to it. And then we're going to drop any non-existing days. Next thing we'll do is set our regression by using linear algebra, least squared models, by passing through our parameters, the adjusted close and the lags. Now that we have our regression model fitted, we're going to create a prediction column where we apply our regression on our data set. And then we want to plot our adjusted close price with our prediction. And we want to see how close the lines match up. So the orange line is the prediction, and the blue line is the adjusted close. And you might be looking at this and asking yourself, well, I don't even see a blue line. That's because at this resolution, where we're looking at the entirety of the decade, the orange and blue line are basically overlapping each other perfectly. So what we'll do is we'll zoom in on a piece of the timeline and see how close they are together. And yeah, you can see the prediction is almost right on with the adjusted close. And so this is a good way to predict the forecast of the index level for the euro to US dollar, and this would also apply to basically any other kind of index. So Bitcoin to US dollar, Ethereum to US dollar, Ethereum to Bitcoin, vice versa. I think this is a pretty basic yet effective way to predict basically the pricing index levels. So you can see it's not completely right on. You know, there's definitely some lag, but that makes sense because you're using a lag to predict where it's going to go. You know, and so you got to determine what your strategy is and whether or not you know, this sort of distance between the actual and the predicted is acceptable or not. But if you passed in this prediction, let's say, into a more like even a deep learning model, that would be pretty helpful for the model to make trades on. So hopefully you guys enjoyed this little lesson on linear regression. Let me know in the comments what you think, and please subscribe. It really helps out the channel. I'll see you in the next video. Bye. Hey everyone, thanks for watching. If you've made it this far, please consider subscribing or watching another video. I really appreciate it. Bye.